Okay. So now if you'll see a data modeling process, so in the data mining, if you see the data modeling process, you go to any data modeling process. Okay. So whatever the project topics that you have, you go through any topics, the list that that has been circulated to you by the Bisal sir. You go to any topic. All these topics involve these steps. So basically what you will have a set of data. Okay. But the data can be in various form. Then next what you will do, you will consolidate that data. You will consolidate those data. Then after that you will identify some kind of relationship among the data that you have received. After analyzing or identifying the relationship, then you will design a predictive model. Then what you will do, you will design a predictive model. Okay. Then after that, when the predictive model is created, then the model is start running. You will deploy that model is start running. After that, whenever any incoming data will come, it will simply predict about your decision, like whether it go for yes or whether it will go for the what, no. It will simply predict the thing whether it will go for the yes or whether it will go for the no. Okay. It will simply predict whether it will go for the yes or whether it will go for the no. Say for example, a file has comes, a computer file has comes. The file is basically the data. The data is in different format. Then what you will do, many such files are come. Many such files, say suppose thousands of files have come. Then what you will do, you will consolidate those files. Okay. Consolidate those files, like some files are of the document files, some files are of the music files, some files are of the video files. You will consolidate those files. Okay. Then after that you have identified the this thing relationship among those like the set of data. What kind of relationship that will identify, that will come into the next chapter basically. So but anyway, you have identified some kind of relationship among those data, those files. After that you will design a predictive model that will predict whether the incoming file is a virus infected file or a clean file. So you have created a predictive model, the model is start running. Now when any such file has come, it will simply predict whether it is a virus infected file or whether it is a clean file. So you are taking a decision and the decision is taken by whom? It is taken by the predictive model. So these are basically minimum steps of any data modeling process. Whatever the topics that you have in your project, all those topics covered these steps basically. Now your goal is to create a model, predictive model that will predict the data, right? So in case of data mining, your goal is to create a predictive model, and that model should be able to predict the data. Am I clear or not? Yes.
Yes, sir.
Okay. Now let us see what is data model exactly. What are the tasks? What are the different stages? What are the things it can do? What is its strength, weakness? Everything we'll learn right now. What is a data model is basically. Now on a broader scale, data model can be conceptual, logical, and physical. So now the model, basically the entire thing is known as what? A predictive model. So in the model where data comes, a decision output. Input is the data, output is the decision. That is the basic goal of any predictive model. So now if we define any model, data model, or basically you can say the set of data, it falls under three types. One is the conceptual, second one is the logical, third one is the physical. Now what is a conceptual model or conceptual data, you can say? It deals and talks about the content of the system. It always deals with the content of the system. They essentially represent the needs of the system. Why you are developing this system? What is its goal? It only indicated by whom? It is indicated by the conceptual model. Am I clear to all of you? It is indicated by the conceptual model. It only identify what? The needs of the system. Am I right? Am I clear to all of you? Conceptual model. Similarly, the logical model. Okay. In contrary to this conceptual model, a logical model always concerned with the domains. Means it is area specific. Remember, it is area specific. Logical model is basically what? It is area specific. They deal with the implementation, how the model will be created, how the model will be deployed, all those things. It will be deal with those things. Okay. So logical models always deals with what? It is the implementation and considers need of the system as well as the deal with the implementation. These two tasks it has been done. Now in case of the conceptual model, it only defines the needs of the system. Why we are defining a model? It only deals with that. But whereas the logical model deals with the needs of the system, as well as the implementation strategy. Both things, need of the system as well as implementation strategy. Am I right? Similarly, physical model. The third thing is basically physical model are the ones that mention the database design and the details of the fields. That mention the database design and the details of the fields. Now, conceptual model works with basically the concept or the aim or the goal of the system. Logical model identified the implementation. Physical model actually works with the data. So now if we see any predictive model, the model is divided into three invisible groups. You can say three invisible groups. One group is conceptual. Okay. One group is conceptual that deals with or identified the need of the system. Logical model deals with the need of the system and identifies the way of implementation. Physical model works with the real data. So these are the three components, you can say invisible components of a data model. But now if you see the data mining really works in the physical model. Okay, and it involves three stages, not the three ways, three stages. One is the data preparation, model generation, deployment. You see over here, data preparation, this up to this, it is known as the data preparation, like these three, this one, and this one. These three constitutes what? Data preparation. Then here and here, it is the, sorry, not here, this one. This is the model preparation and this is the model deployment. Once you prepare the model, then you will deploy the model so that it will start predicting the incoming data. So these are the three stages. One is the data preparation, model generation, and the deployment. So the data preparation is also known as the pre-processing of data. Pre-processing of the data. Now why pre-processing is required? Remember one thing, if I will provide you certain data, a set of data, random data, and if I'll provide you data related to students' personal information, students' fee structures or fee payment history, student disciplinary cases, student library books details, okay, and students examination performance, score, marks, everything, all I will provide in one space by mixing up. And if I will ask you, can you predict if this student's name is this, okay, its last exam score is this, say suppose in subject 1, subject 2, subject 3 score is say suppose 30, 40 and 70. Now can you tell me like whether the student will pass the final exam or not? You have data from all sort of areas. Now what you will do, you will design a predictive model that will predict whether the student will pass the final exam or not. But will that predictive model will works on the library data to predict whether the student will pass or not? Whether that predictive model will works on the student's fee structure to decide whether the student will pass or not? Whether that predictive model will works on the student's personal data to predict whether the student will pass or not? Is it? I don't think so. Only what it can predict is basically if the model is built upon the examination data. If the model is built upon the examination data. So what I'm trying to say is like this: you have data from a lot of resources. So you will pre-process and extract those data which is relevant to your model, predictive model. But now if I will ask you, can you predict one thing like if which of the students are the lowest performer in the college in all aspects, in terms of fee payment, in terms of say suppose disciplinary cases, in terms of say suppose examination? Can you predict a students overall which student is the worst performer and which student is the best performer? Can you predict? So in that case, what you will do, you cannot work alone on the examination data. Then in that case, what you will need data from various sources. So are you getting my point? So data preparation is entirely depends on your goal. What kind of data, what goals that you are identified, or what area that you want to explore, or what area that you want to predict. So based on that, based on the goal of the predictive model, you will decide the set of data that you want to consider. So you cannot work directly on the data which is available to you, which is available to you. So what you can do is you can fetch relevant information from your data. So that process is known as data preparation. I will show you why data preparation is also required. Here, see what are the things that has to be taken care during the data preparation. So data preparation is sometimes referred to as the data pre-processing. It deals with cleaning, you see, data cleaning, transformation, and selection of data. These are the three main steps of the data preparation. So a project is identified for all of you. Okay. So that in order to execute that project, there must be some underlying data. For that project, there must be some underlying data set which is available on the net itself, underlying data set. So now if you see that data, you cannot use that data to design your model or design your project. You have to first clean that data, then you have to transform that data, then you have to do what? The feature selection or the selection of the data. What are these three steps that I will discuss right now, and how you will do it, that also I'll discuss right now. Now prior to the analysis, analysis means the model. Prior to the model, it is necessary that the potential features be identified that can be yield effective outcomes from the prediction process. This is what I said, predict potential features. If you want to predict whether the student will pass or fail, in that case, students fee structure or fee details is not an effective potential. This is not a potential feature. Students age, gender, its personal habit, that is not the potential features. So what is the potential features? How much score he has received during his class 12, how much score he has received or she has received during his class during his graduation, how much score he or she has received during the first semester, second semester, third semester, fourth semester, and fifth semester. Then only you can predict, okay, in the sixth semester the student will pass or fail, right? So in that case, what is the potential features? The potential features are the features or the scores related to the examination only, to the subjects only. That is basically the potential features. So here, before the classification start, before the predictive model starts working, you have to identify the potential features. So based on the potential features, your system will works. This is what I said. Data pre-processing entirely depends on the nature of the problem at the hand. What you want to identify, what is the task in hand, whether you want to predict the students pass or fail criteria, whether you want to predict whether the student will be defaulter or not. If you want to devise a system, if I will feed some data to the system should be able to identify whether the student is going to be defaulter in the coming semester or not in terms of fee payment. So in that case, you have nothing to do with your examination data. You will take with what? The his or her fee payment history, right? So it entirely depends on the nature of the problem. Am I clear to all of you? Data preparation. Now, the stage needs to look at the transformation, feature reduction, and normalization. These are the three steps: transformation, feature reduction, okay, and normalization. Same thing I said over here: cleaning, transformation, selection. Okay. So now what is a transformation? Sometimes transformation and normalizations are used interchangeably. In some books you will find normalizations are interpreted as transformation. In some books you will find normalizations are different from the transformation. It's only about you that how you will identify it. Now let us see what is data. You have understood right now what is data preparation, right? Yes, am I clear?
Yes, sir.
Hello. I will show you one example, then it will be clear to all of you in the context of your program. Okay. Now, suppose you want to devise a predictive model, a classification model, when a patient come, and if I will put some information about that patient, the model should be able to identify whether that person is suffering diabetes or not. Whether that patient is suffering or the person is suffering diabetes, or he is or she is a controller in normal patient. Suppose you want to devise this model. So I have a data set for that. Here I have 4 data sets. Now you see the data set. I am opening data sets one by one. What is the goal? First, to identify the goal. Goal is basically to design a predictive model. And you have this data. You have this data. So now here, if I will see the data, I have the patient ID, okay, outpatient number. Whenever you visit to any hospital, 2 types of numbers are generated. When you visit to any hospital across the globe, so if you are just visiting to a doctor, then you have a number is generated. That number is known as what? Outpatient department number. Okay, outpatient department number. But if you will be admitted, again a unique number will be generated. That is known as what? Inpatient department number. Sorry, inpatient admission number. So this is basically inpatient admission number, and this is basically outpatient admission number. Then you have patient information like whether what is its race, gender, age, weight, admission type ID, discharge disposition ID, admission source ID, and also it has many more informations like these things. Its blood measurement parameters, its glucose level, everything is there. All this information there, and our target is by using, and also BMI, body mass index, then a DP function, trifold skin thickness, everything has been there. But now you want to design a model. So now when a patient, so suppose a random patient comes with this information, random patient will come with this information, my model or our model should be able to predict whether that patient is a healthy patient or a sick patient. So for all these data, we have information like whether the patient is sick or whether the patient is healthy. Okay. So now I will feed this data to the system, and whenever a patient will come with of a certain race, of certain gender, of certain age, with some weight, with some admission type ID, then my system should be able to predict whether that person which is coming for the diagnosis, whether he is suffering a diabetes, sick means diabetes, or whether he is a healthy. Okay, so this is our target. So now we have all this data. Now you tell me, can I feed these data directly onto the predictive model? Whatever model I will create. I have not decided what model I am going to create or what is the algorithm that I am going to use. But my question is, should I put all this data to the predictive model? Will the model works perfectly? May works, may not works. So first what I have to do is I have to clean the database. Why the cleaning is required? Now if you see this database, look at the weight field. Weights are labeled as 0, and in between somewhere we are having some information, so like say for example nothing. The weight is completely 0 for all patients. Okay, sometimes in between there is a some weight like 62.5, 62.5 is there. Otherwise mostly the weight is what? The weight is 0. So now in that case, does this attribute is relevant to my model? Will it work? Dekho, you are designing a system, that system will be based on some data. But now you have some attributes which is completely missing data, or 99% data is missing. Does that attribute is required? Obviously it is not required because it is missing information. So in that case, the best practice is you have to clean the data. You have to clean the data means either you have to fill off it with some appropriate values, with appropriate weight, which you cannot do. So the better idea is remove this attribute. So before the actual processing, you have to remove the attribute. So what I am doing over here, I am transforming the data. I am transforming the data. Okay, so entire data was there. In earlier case, the data has how many attributes? Suppose 56 attributes. Right now, I have removed one attribute. Similarly, you will see whether any attributes you need to remove or not. Look at these parameters. If something is totally 0, then it is the good idea to remove that attributes. This is one thing. Second thing is that not all attributes are essential for the detection, whether the person is suffering diabetes or not. All the attributes are not required at all. So for example, so like what the predictive model will do with the patient ID. A patient ID say, can you identify whether the person is suffering diabetes or not? No. So these attributes are, this is the, of course, any layman will say these attributes are not required. So we have to remove these attributes also. So basically our target is we will select those attributes which are relevant to your model. That is the first stage. This is what I said over here. First, what is need? It is needs the cleaning. Similarly, let us see one more data set. Say suppose data set 2. Look at this data set. It's a similarly another data set, okay, that represents whether the person is positive for the diabetes or he is a normal patient, then negative. Here the positive indicates the person is suffering diabetes, negative indicates the person is normal. Okay, this is the result of diabetes. Now in this case, you tell me what are the attributes or what are the data that has to be cleaned. Yes, anybody of you?
ID.
ID, okay, I'll remove the ID. ID is not required. Okay, fine, done then.
सर वो हिस्ट्री ऑफ क्या है सर? व्हाट इज दैट हिस्ट्री ऑफ सर में
हिस्ट्री ऑफ ब्लड प्रेशर, उसको ब्लड प्रेशर था कि नहीं था?
BMI.
यस,
Body
BMI.
mass index.
Okay, body mass index. You think it has to be removed. Okay. Anything else? Can you tell me whether if I'll pick up any row, whether all the data is perfect? You see, there is an attribute. What is the use of null value over here? That means the data is incomplete. It has to be cleaned, isn't it? You have a project to develop and you are developing that project on certain data, and the data is contains some kind of missing values. That is called what? Missing values, the null values. So what you will do, what is the idea, what you will do? You have to work. Either you will remove this row which contains null, this contains nulls. Either you remove these rows or remove these columns. Both you can do. Either you can remove these rows and remove these columns. Okay, because null values that will not allow you to predict your model. Suppose you are using a Navy Bayes model, or you are using a Bayesian network, or you are using a decision tree. Those models may not work on the null values. You may get a runtime error. So it's a good idea to remove the missing values or adjust the missing values. These two are two different things. Removing the missing value is quite easy. Simply select this thing and delete it. It's removed. But if you will remove this missing value, but at the same time, it also leads to loss of a lot of valuable information, isn't it? These informations are required. बाकी सारा information तो था. सिर्फ ये 2 3 4 के लिए तुमने बाकी सबको भी remove हो गया है कि नहीं? So if I'll remove these rows, then many other valuable informations will also be removed, which may enhance your process of detection. Similarly, if I will remove these columns, look at the cholesterols, the HDL, these are very good parameters for the diabetes detection. So if I remove these columns, just for these 5 or 10 patients, you are removing a valuable columns over here. Then what you will do? How you will adjust these missing values? I'm talking about data cleaning. So what you have to do is you have to clean the data. Cleaning does not mean like you delete or the data. Delete is the last solution. If you see in this column, 99% data is blank or null values. In that case, it is you can remove it. You cannot do it work with that attribute because almost all data is scrambled or wasted. So in that case, you remove the data. But in this case, it is not 99% data is corrupted. Only few data is corrupted, isn't it? Only few data is corrupted. So as a database engineer or as a data analytics engineer, what you will do, you have to adjust this data. So I will assume that if this indicates FBS, if this indicates cholesterol, I will put certain values over here which is approximated, may not be exactly equal, may be approximated values. So what I will do, I'll calculate the average equal to average. So average is this, okay? Then whenever I will find missing values for this cholesterol, I will paste it. I will paste that values. Whenever I will find null values over here, I will paste that value. So what I am doing, I am adjusting it. Since all are in the round figure, I will try to make it a round figure. Done. Now what I have done is basically the null values are replaced with the average value of the series. I can use average values, I can use the standard deviation values. Okay. It depends on the application. So what I have done is basically I have cleaned the data. Now the data seems to be complete for the attributes cholesterols. Similarly for the FBS, similarly for the triglycerides. So here just I have done some kind of approximation. I have handled the missing values using what? The statistical approach, like using the mean of the data, or I can use the median of the data, or I can use the mode of the data. Am I clear to all of you? There are also a lot of advanced approaches are there to replace the missing values. Like someone may use the rough set approach, someone may use some different approach. So it's entirely depends upon the final predictive model that you are going to create. So choosing a right approach to replace your data, choosing a right approach to pre-process your data is also a challenging task. The more you expertise in this area, the more nicely or beautifully you will be able to handle these missing values. Okay. Now another approach, you see, someone may argue, I just said like you will replace the data with some kind of missing values, some kind of like the this thing average of the data. I have just replaced the data missing with data using what? The average of the data. Okay. Now someone may argue some more, if you will be more professional or if you have more experience, then what you will do, you know well data of a specific class which are positive. Now if I will just instead of this changing, what I will do, instead of this changing, what I will do, I will just sort the data based on positive and negative. Data sort the last value, that is the result of the diabetes. Okay. So all these patients are negative, having no diabetes, and similarly all these patients are old patients and few patients are positives. Okay. So we have this data, negative and positive. Now as a data analytics professional, you know the data related to a specific classes are close to each other. The distance, if you calculate the Euclidean distance between this patient and this patient, you will find these two are quite close to each other, because they are that is basically the history, its cholesterol level, its HDL level, triglyceride level, you will find almost similar. That is why they are negative. If you see the positive patients, they are like figures, these values for each and every attributes will be quite similar. That is why they are positive. Definitely their cholesterol level will be more than 300. Definitely their blood sugar level will be more than say suppose 400 or 500. Definitely. That is why they are positive. And why they are negative? Because it's these figures values are much more in the normal figures. So therefore averaging a missing value, so averaging a column for all rows is not that much of viable. The better approach is basically what you can do, if you want to replace this null values for say suppose HDL or cholesterol, if you want to replace this value, so instead of calculating average of entire attributes, calculate the average of what? The persons, those who are suffering negative. Up to this. So the value that you will get more precise value than that of you are calculating average on the entire data set. Are you getting my point? Here I have calculated average of all the negative patients because I am going to replace a rows, because I am going to replace a row values of a negative patients only. I cannot consider the positive patients. Are you getting my point? You can also do that, but the more you will be experienced, the more you will able to learn like in what basis I will calculate the average. Someone may say like if this patient is coming over here, ID, if this patient is coming next time, suppose this is the ID, and if this patient is coming next time over here, so in that case, in the first case, if it is having a cholesterol value, then just if this time over here, if the cholesterol value is missing over here, in that case, replace this cholesterol value with the cholesterol value that has been reported earlier. That is also another approach. So there are many approaches are there, but the thing what I am telling is basically you cannot process the data directly into a predictive model. What you have to do is you have to first what the transform the data. You have to first what the transform the data. That is sorry, cleaning the data. So you need to clean the data. Then another task is there, the transformation. We will see the process of transformation in the next class, how to transform the data. I will also show you similar kind of examples. Or you can come up with your project approach. We will discuss in the context of your project also, right? So have you understood what is data cleaning?
Yes, sir.
See, in the